So good day again, everyone. So I am again Prudence is Bustamante. So I am a physics instructor in Surigao del Norte State University. Today we're going to answer the exercise 3.2 of under section 3.1 position and velocity vectors. This is under the chapter 3, which is motion in 2 or 3 dimensions. Again, we are using the University Physics with Modern Physics 13th edition. Okay. So in the problem, a rhinoceros is at the origin of coordinates at time t1 is equal to 0. So for the time interval from t1 is equal to 0 to t2 is equal to 12.0 seconds, the rhinoceros velocity, average velocity has x component negative 3.8 meters per second and y component 4.9 meters per second. So time t2 is equal to 12.0 seconds. What are the x and y coordinates of the rhino? And how far is the rhino from the origin? Okay. So let's first make a coordinate system. So say for example, this is our x and y coordinate system. So this is the origin. This is at the origin. So at the origin, x is equal to 0 and y is equal to 0. So so if so this at t1 is equal to 0, then and it is in the origin, therefore our initial position is equal to 0 and our initial position along y is equal to 0. So we are in the origin. Okay. So so after 12 seconds, after 12 seconds from so we are now in some point in the coordinate where we have an x which we do not know and we have y which we do not know. Which we do not know. We are in that some positions. We don't know what is the position of that in our coordinate. Okay. So so we are given the x component of the rhino's velocity and we have y component of the rhino's average velocity. Okay. So how do we answer this problem? For letter A, so we are asked to find what is the x and y coordinates. Okay. Let's use the formula. The V average for the x component is equal to the displacement, which is the final position, okay, minus the initial position over the time interval, which is t2 minus t1. Okay. Uh the same for let's put this on V average along y is equal to y2 minus y1, okay, over t2 minus t1. Okay. Here, this is our x2 and this is our y2, which we do not know. Okay. So so here we know that our x1, since we are from the origin, so this is equal to 0. This one also t is equal to 0, 0, and this one equal to 0. And we know that our average velocity is just equal to negative 3.8 meters per second, and also this one is 4.9 meters per second. Okay. So so we can now rearrange that one. So we can find the coordinate x. So using our algebra, since since V average along x is just now equal to uh, negative 3.8 meters per second is equal to the x2 over t2. Okay. It implies that our x2 just, so since this is 12, x2 is just equal to negative 3.8 meters per second multiplied by t2, which is 12.0 seconds. Okay. So let's put here x2 is equal to uh, negative 3.8 meters per second multiplied by t2, which is 12.0 seconds. So it will give us so negative 3.8 multiplied by 12. So we will have negative 45.6 meters. After 12 seconds, our x coordinate is 45. So here, negative. So along this negative line. Also, the same method, we're going to use the same method. It implies that our y2 is equal to 4.9 meters per second multiplied by 12.0 seconds. So our y2, okay, 4.9 times 12. So we will have 58.8, positive 58.8 meters. Okay, that is our, so that's basically our coordinate. So so if this is y is positive, this is 58.8 meters, and if this is our negative, uh, if this is our negative 45.6 meters, okay. So our coordinate is in quadrant 2. Okay, so this is somewhat, so our x2, okay, x2 y2 is just negative 45.6 meters and 58.8 meters. Okay. So so that is our coordinates. 58 and negative 46.1. Okay. So to find the, what we call this one, to find the letter B, for letter B, so let's erase some space so that we will have some space. Okay, so we are now ready to answer letter B. So how far is the rhino from the origin? So this is actually the distance of the the rhino from the origin. So here, so this is actually R. So the position R. So R is just equal to, since we have here what we call this one, right triangle. So our x is this one and ry is 58.8. So we have negative 46.45.6 meters squared plus 58.8 meters squared. So that is our distance. How far is the rhino? Okay. So we have negative 45.6 squared plus 58.8 squared. So our distance from the origin is 74.41 or 4 meters. So we are in, so this is the distance R. So this is actually the distance R. So that's the distance. So, okay. So our coordinate is this one and this one, and our distance from the origin is this one. Okay. So for more videos like this, please click subscribe and like our videos. And if you have some problems that you want us to answer, please comment that in the comment sections. Comment section. Thank you and God bless everyone.